In this video, we're going to take a look at doing what is commonly referred to as essential services, or as I've affectionately called it, network management VRFs, or I should say, not VRFs, VPN services. So basically what we're going to do is we're going to set it up to where router 9 is going to be our deciding factor. So we're basically going to set up hub and spoke MPLS VPN. So if you've watched any videos of mine in the past where we've done hub and spoke MPLS, hub and spoke frame relay, hub and spoke DMVPN, that type of stuff, this is where this comes into play. Now all we're going to do is we're going to create a route target import export policy to where all we're going to do is we're going to take on 11, 6, 7, 8, and 10, we're going to create an export policy that's going to say we are going to export to 65,000:900. That's going to be our route target export, and then we're going to do an import of 65,000:900 on router 9, and that's what it's going to be. Now, by default, what ends up happening when you're doing your route target policies and things like that, you have to be careful with it, because if you're not careful with it, what can end up happening is there is what they refer to as a default route target filter. Now what that basically means is if you don't have a VRF with a route target associated to it, then what's going to end up happening is if you get a route target that comes inbound to the router, regardless of what VRF it's supposed to be going to, if you receive a route target inbound to the router, it's an import, what's going to end up happening is the router is going to look at the route target and say, okay, do I have a VRF that is supposed to be matching that route target import or export policy? So is there a policy that states I should be looking for a particular route target value? Now remember, a route target value can either be a dotted decimal, colon, and a number, so like an IP address, like a router ID, or a loopback number or something like that, and then typically some random value after that. Or it could just be look like a BGP community, where a BGP community can look like 200:20, something like that. So the way that this is actually going to work is we're going to set up an export policy on 11 and 10 and 6 and 7 and 8, and we're all going to drop them on router 9. What that's going to allow us to do is it should allow us to see routes coming inbound from these guys. And the whole purpose and premise behind this is when router 9 receives these imports from the other, what would be considered to be spokes, the spoke routers, what's going to end up happening is this is where you would have your SNMP traffic coming from, things like that. So it allows you to have a hub and spoke type of setup. Now, we're still doing full mesh on the back end. So we still have a full mesh of IBGP connections between all the other routers. In upcoming videos, we're going to be doing partial mesh, which means we'll be doing a partial mesh of VPN or IPv4 route reflection, and then we're going to move ourselves into IPv6 MPLS down the road. But it's going to take a little bit of time for us to churn through all that information. But what we're going to do is I'm going to pull up our routers here, and we're going to get this set up here momentarily. Here, let me bring this down. Now, I've never actually configured this myself, so it's going to be interesting to see exactly how this plays out. But I've heard it's really, really easy to do. So we're just going to get rid of the OTB setup right there. Now, what we have to do is we have to go to every router, and we have to set up. We have to set this up. So what we're going to do is we're going to start this on 9. Why does it do that? Ever since I've started using SuperPutty, and it's weird the way that it works. I don't know why it does it, but it does. I do a single click on my mouse and it kicks it out. So I'm not sure if I'm just clicking long enough to make it want to kick it out, or because if I grab this and I move it, it'll pop loose. So it might be just that. But anyway, we're going to start at router 9. I'm going to do a show run VRF. Now that's just going to give us our breakdown. Now as you can see, we have, where is it? Right here. So we have our import and our export set up right here, right? So what we're going to do is we're going to take this, we're going to have an import policy for just this. We're going to say 65,000:900 is what we're going to have it as. So we're just going to copy this and we're going to the definition brown. This is locally significant. That's one of the things that I often get emails and references for when we start talking about MPLS. The VRF definition is stating the name of the local VRF, because VRFs, remember, are locally significant. It's just like the OSPF process ID number or the EIGRP name, a named mode, things like that. They are locally significant. They do not transit between routers. It's not like an BGP local preference where it transits everybody in the local autonomous system. It doesn't do any of that. So you can have whatever the VRF name is, that is arbitrary. It doesn't matter. But what we're going to do is we're going to flip this around to be an import policy of 65,900. So we're going to take this guy right here, and we're just going to go to global config, right click and paste this in. We're going to hit the import policy and say no, and we're going to say the export policy, we're going to say no, because we only want to bring routes in. Now this is like I said, this is basically going to be hub and spoke. So we're going to type in route-target import is going to be 65,000:900. And the reason why I'm going with that is because of the fact that this is BGP autonomous system number 65,000, because that's the MPLS provider, and then we have 900 being router 9. Alright, so now what I'm going to do is I'm also going to go to the other routers. So 6, 7, 8, 10, and 11. So I'm going to start on 6. I'm going to do show run BRF, and I'm going to just copy this information right here. So I can, unfortunately I have to go to every one of these, and I have to VRF definition blue, and I have to go to type in no on that and go to the export and type in no, but hit the up arrow and go to the beginning and then pull this in, go to the end of the line, and then whack these guys out. There's going to be 65,000:900. Now before I do that, let me go to router 9. And let's do this. Let's do a show BGP VPN v4 unicast all. Alright, so we're still getting routes in from router 9. So we do a show IP route. Show IP route. Let's see here. What is 19 seeing? Show IP route. Okay, since we broke it. So yeah, so we shouldn't be getting any routes. What I'm going to do is I'm going to do a debug here. I'm going to do a debug IP routing, which this basically, whenever we get a routing update, this should trigger. We're also going to do config T. No, you know what? I was going to do a debug IP route profile, but we don't need to do that. What I will do here is I'll do a debug BGP IPv4 unicast updates. So I want to see when routes come in. So I'll just be able to click on 19, and we should see a bunch of updates coming through. So on 6. Again, I did it again. So on 6, we're going to hit the route target export is going to be that. So now we have that. Now we should go to 19, and eventually we should start seeing routes coming in. Now you know what? I bet you any money, since we gotta redistribute on 6. Oh, I did it again. So what we're going to have to do is we're going to have to do a show run pipe section router and see exactly what we got going on here. And let's see here. On 6, let's see here. We need to do redistribute BGP, redistribute BRF red. Oh, you know why? Because I don't have blue redistributed. That's why. because blue is supposed to be for, what was blue? Blue was, I forgot, to be honest with you. I blew all that away. So blue is not getting redistributed. That's why it's not working. I gotta redistribute into that guy. That was RIP, was that guy. So I didn't go into RIP and redistribute. I need to go to RIP and I need to go redistribute that. So config T, router, RIP. I type in address family, IPv4, unicast, or VRF blue, and hit enter. And I type in redistribute VRF, or just redistribute BGP 65,000. And actually, no, let me do the transparent metric. Metric is going to be transparent. And let me do that. So then, if we go over to 19, again, we're killing me, Smalls. Okay, so we got a routing update, which is good. That's exactly what we're looking for. So we should be receiving routes in. We do. So if we do a show IP BGP, we should have some routes in here. And now the drawback to these guys is they're going to be traffic from from router 5 to router 19, but not from 19 back to 5. Because of the fact that we are doing what they consider to be central services VPN. So basically what you're going to be doing is you're going to be sending everything from your spoke sites up to your HQ. So now that we've done that, we should be able to we will be able to on 19. So if we go to, let's go to 5, and I don't think we'll be able to see anything on 5. So show IP route. Yeah, I don't see anything coming in from there. But anyway, that's router 6. So what I'm going to be able to do is on router 6, I'm going to be able to do the exact same thing for the other VRF. So show VRF. I did. Now see how I got the blue in here is ready to go. And now I need to go in and do the same thing to show run VRF. I need to do the same thing to red. I need to go change the route target export value. So I'm going to go to config T. VRF definition is going to be red. I need to type in no and pull this export value out, and change the import value as well. And type in route-target export is going to be 65,000:900. And then I'll go to 19, and then we should start receiving routes in here momentarily. There will be an update timer. And unfortunately, it's not going to be as quick as it is with no, that was red, so that was OSPF. Right? Let's see. 19 get it yet? Yeah, there it goes. Okay, yeah, it just takes a couple of minutes. Yeah, see, that was OSPF from over here. So we get those routes coming in. Now if we do a show IP route, we have a bunch of routes coming in. We do a show IP BGP, we get a bunch of routes coming in. So again, it does pan out to where this does come in. Now this is, again, Central Services VPN. Now let's go, now that we've got it set up on this way here, we'll be able to take a notepad document, like this guy, and we're going to be able to just tweak these guys. So we'll be able to go to 6, and then do a, jump out of here, and then do a show run VRF blue, and then we'll be able to just take this information right here, and copy it in. So literally that's all we'll have to do. And we just copy this information right here, and get rid of that, paste that in here, and we'll go to 7, and we're going to go down to show run VRF, and that information is right there. So I'll just be able to take this out and do this and type in, or actually no, what we'll be able to do is red, and we will come down here And you know what? We'll pull the RD out here, and I'm just going to copy and paste this right here. Because what I'll do is I'll just copy and paste this into global config, and it'll be quicker to do it this way. Just type a no in front of each one. This is where, when you're playing with this stuff, is going to be inherent to going through and understanding what it is you're trying to accomplish. Actually, I can just do this, and see, this is what you need to do. So the RD stays the same, so we don't need to mess with that. It's just the route target value that we need to modify. Oh, no. And once we get the route target modified and we start doing this, we just be able to copy and paste this, like so, into global config. And right click and paste, and that should be all we need to do. And then on 19, momentarily here, we should get the routing update. Now this is coming from OSPF, and so there we go. We get the routing update going along. Everything looks good there. Show IP BGP. We have additional routes. So same thing goes on for router 8. We're going to jump in here and drop out of here. Go show run VRF and pan up to the top here. And we're just going to copy this out and wall up this. We're going to make this brown. And we're going to nope here. And no route target there. Instead of having to retype everything in, it makes it a little quicker. And on a momentarily, and now yeah, I am taking intentionally taking the time to update this. And yes, because we were on router 8, it was directly connected to the same BGP autonomous system number. It should be a little quicker, and that is true. So we'll go to 10. We don't have to do this on 9 because 9 is acting as the hub. So what we're going to do is we're going to go in here and go on 10, do a quick show run VRF, and we are going to, again, just copy this information out. Now it just becomes repetitive. And I know you guys, you don't have to sit there. You can fast forward the video if you'd like, but, and no route target there, and make this green. Green. Also, make sure you type it incorrectly, because remember, these are case sensitive, and if you mistype anything, that could be a bad day. I actually did that once in production not too long ago. Thankfully, it had nothing to do with VPN, or actually it did have it was actually a VPN. It was an IPsec VPN. I changed the phase 2 negotiation. Tunnel goes down. I didn't even realize it, and all of a sudden we get a phone call, and I'm like, hey, the VPN, we can't get an AD replication to go across our circuit. I'm like, what? How did that happen? He goes, well, I don't know. You were the last one to mess with it. Oh, okay. Let me take a look. And I went in and I was like, huh, how'd that get changed? I noticed it got changed by me. I'm like, oh, okay. Because we have CBAC enabled, and I was able to look at the, log into the TACAC server and see exactly what happened. So, yeah, I screwed up the VPN. But fortunately, I know enough about that type of stuff to know how to fix it. So that was and actually, we don't even have to worry about that because we can just copy and paste this guy in. Because 11 and 10 are the same VRF. Config T, right click and paste, and there we go. So now we can go to 19. We should be getting routing updates here momentarily. And 10.132. So, yep, we did. So if we do a show IP BGP, we have a bunch of routes in here. But if we go to any of the other routers, so say for instance 6, we do a show IP BGP, we shouldn't have anything. Show IP route, nothing. We shouldn't have any BGP routes in here at all, which is good because everything we're doing here is getting advertised over to this guy. Now we could go into OSPF, but because we're doing redistribution from OSPF, let me just explain this real quick. So right now what we're doing is we're exporting. I'll just draw an E next to all the locations that are doing this. We're doing an export at all these locations. And again, this is for a central services central services VPN. So we're sending all of our routes, we're exporting them up to router 9. So this is a unidirectional MPLS setup. So we're sending everything to router 9 and up to that route. Now what we could do is we could have a route target export on 9 pointing this direction. That is 65,900 or some other value that we could say that we only want to have certain sites receive certain routes. So we could actually go in here and say we could have it set up to do one. We could have it set up to do certain sites could be the only ones to receive routes. We could have certain sites set up to receive only certain routes, and you can actually do this by having it set up to where you can import certain labels. You can have it advertise certain routes, and the cool thing about it is you can also on the router itself at the IGP level, you can do a distribute list. You could do depending on the IGP. If it's OSPF, you can do a database filter. You could do a prefix summarization. You could do a prefix suppression. So there's a lot of different things you can do with it in regards to how that would be set up. But right now, if we look back at R19, R19's got a whole bunch of routes on it because of the fact that our configuration. So we have all these routes in here that are coming in from BGP, and if we were to trace route to say 10.1.103. 103, where did that come from? 13. 10.103, 10. Oh, I lost it. 10. You'll find that, you know what I should do is I should disable no IP domain lookup. That should increase the speed of it. Well, I'm going to see if it's even going to trace route to it. I don't think it's going to. I've never actually tested it, but I don't think it's going to work. Oh, it is. Okay, cool. So, and the reason why, well, and it's going to get to router 9 because he doesn't know how to get to it. But, let me do this. Let me go to View and Toolbars and Send Commands. Now, if you don't have this capability, that's okay. So, what we're going to do, whoa, what just happened? It freaked out on me. So, what we're going to do is we're going to go my computer. And we're going to go to config T, and we're going to type in no IP domain dash lookup, and enter. Oh, everybody put in the A, huh? Alright, so now what we're going to do is we're going to end out, and we're going to go 2, 3, 4, 4 got it. 5, 6, 7. There's a question, what's the purpose of using that? The reason why you would want to use no IP domain lookup is it should speed everything up, because what's going to end up happening is it's going to try to resolve the name that you're trying to trace route to a name. So if you try to trace route to anything, it's going to try to do a domain lookup on it, and you don't want that to happen. It's supposed to speed up your trace routes and things like that. So that exact same thing we just did a minute ago, we're going to try it again. Now that we have, alright, cool. So, we're going to do that trace route again on 19 to that site we just did. See, notice how it comes back so much faster? Now the problem is it doesn't know what to do with it. It doesn't know where to go. Because what we're doing is we have it set up right now to where when it goes from 19 to 9, it gets to 9. So if we were to do a show IP BGP, right, we know what our next hop is. Now when we get to 9, okay, router 9 is going to be our next hop. We get to 9, but when we do a show IP BGP, we got nothing there. So we could take this a step farther and go, okay, we need to make sure that we need to get to that location. But if we do a show IP route, the problem is we're looking in the wrong place. We need to be looking at show VRF, show VRF brown, or no, show IP route VRF brown. I don't need a VRF brown. And we have all these routes right here, right? Well, we know that we're getting a bunch of routes in here from these guys, right? So what ends up having to happen now is either I don't have my redistribution set up correctly, or I'm not exactly sure what the problem is with that. But if we were to do a trace route to 10. Or trace VRF brown to 10.1.103.10. Do I not have my show run pipe section router? And what this is going to do is it's going to show me my import export. So I am doing okay, show run pipe section OSPF, or no, this is BGP. So I don't need to do redistribution here, but that's part of the problem. So what I would need to do, it's actually a good question. So if I was to do a show IP route, what do I get? Notice that some of those routes don't show up here. So the 10103, because they're in VRFs. So I would have to, let's do show MPLS forwarding table. Interesting. Well, it's not really interesting. I think I know what the problem is. The problem we're running into is when it hits router 9 doesn't know what to do with it. So it's basically saying, hey, you got this route here, and I think we would need to redistribute the route into BGP from R10 into it. Is that what we need to do? Go to router 10 and then do a show run pipe section. Show run pipe section BGP. Because what we're doing now, redistribute EIGRP 112. So we're getting the route to come from EIGRP into BGP. Then we get that redistribute BGP the metric. So that's fine. What we have a problem now is when it hits BGP, we would need to redistribute from BGP. See, it's coming from this guy. It's coming from EIGRP into BGP, but it's still in the VRF right here. So this is BGP. This is See, this is BGP redistributing EIGRP into it, but in the VRF. So I'm not exactly sure. That I'll have to come back to. I'll have to shoot another video on how to get that to actually work. But I wanted to shoot a central services VPN to where the route will be able to be received by 19, just to get the actual data plane or the control plane set up correctly. The data plane, I'm not exactly sure where I'm going wrong with that. If I need to pull something out, just trying to think here on the fly. Pulling it from EIGRP into BGP. So BGP should have it over here. But see, it's going from VRF to VRF. So it's in the VRF table. I wonder, could I redistribute from... No, I wouldn't be able to redistribute from BGP. I can't... On the same router, I don't believe you... As far as I'm aware, you can't go from a VRF into another VRF. What I would mean by that is, so we can't go from VRF green here to the global BGP table. Because technically they're both VRFs. It's just that when you're dealing with the global routing table, you don't see it as a VRF. You see it as a global routing table. So that's where it gets. That's why when I refer to like OSPF and EIGRP before you go to a specific address family, I consider that to be the global process. When you go to address family IPv4 or VPN-v4 or VRF whatever, that's going into a specific address family. When you're in the global process, that's a global process. Even though you're in the global process but underneath an address family, you're going from EIGRP VRF to BGP VRF. But then from this guy to here, I think we would have to do another export policy? Or no, we'd have to do an import. Because this guy's not importing anything. He's not exporting a particular file. Because what we could do is we could have an export per site. So we could say, from here we could say 900 colon something, and where it's coming from and going to say router 10, so router 1000, 1100, 600, 700, 800, whatever you'd like. So we could do something like that, and then have it receive it inbound. So it should be able to receive, because right now it's unidirectional. it's sending routes up to router 19, but router 19 can't send traffic back. Because remember, routing is bidirectional by default, so if you don't have it set up that way, that's my guess. Let's give it a quick shot. I'm just curious now if that would actually work. So on router 9, let's go to router 9. Let's do a config t do show run BRF. And what I want to do is I want to take a look at. Alright, so our import policy is that. What I'm going to do another import policy for. I want to do on Brown. I want to do an export policy. Our export policy is going to be 65,000. We'll say 900 to 65,000. So we're going to go from router 9 into the global process. Or no, I'm sorry. From the BGP BRF into global BGP is what we're going to do. And then on all these other guys, we're going to set a bunch of, so on green, we're going to have an import value of 900:65,000. So we're just going to see if this will work. BRF definition Brown. I'm just curious now at this point. So we're going to go to global config. So we're just going to copy and paste this guy in. Alright, so that's going to be that. Now we're going to go to router 10 and see if this will actually work. We're just going to copy this information right here. Now, you can do that. You can have a separate route target import export policy per provider edge router if you'd like to do that. Because remember, they're locally significant. And we're going to type in, we'll say that. So now, if we were to go to show BGP, VPN before unicast, VRF green. Okay, so we are getting routes, and which is good. So, but see it's but it's coming from these guys. So if we were to actually go, let's do a show IP route real quick. We're not learning anything from BGP. Oh no, I'm sorry. It wouldn't be 10. We'd be learning it from. It would be 13. So show IP route, and we're getting, right here. We're getting an external route 10.19.100. If we go to 19, and let's just use you all here. Clear all this garbage up, and we're going to do a show IP, or no, show run pipe section BGP. Unfortunately, we gotta grab this real quick and scroll up just a little bit here. Too far. Right there. So the network 10.19.100, at the very bottom of your screen, 10.19.100.0/24. We're getting that on router 13, right there. So now if we were to go to a trace route to 10.19.100.19, we'll get to router 10, but router 10 doesn't know what to do with it. So it's kind of broke. Right, is that the actual IP address? Show IP interface brief. Yep, that's the right address. Did I type it in right? 10.19.100. Yeah, I typed it in right. So at least the route is showing up, which is a good sign. So, it's showing up as a EIGRP external route. So it is coming in correctly. So why it won't... Let's go to 10, because 10 is the common denominator. So stuff coming in. So show run pipe section EIGRP pipe BGP. And let's see what's actually going on here. Because this is where the investigative part comes into play. So we have a redistribute BGP 65,000. on that guy, we have a redistribute EIGRP 112. So we are redistributing the route. Let's do a show EIGRP address family IPv4 VRF green topology. Alright, so here's what we got. We got this route coming in, and if we do a show IP route VRF green, we have the route. Or no, we don't have the route. Do show IP show IP route. What's in? That could be the problem. So it's in the topology. Oh, okay, it's in the topology table, but it's not. I see, because it's an external route. The feasible distance is so high, it's not being added to. So 10.1.12 is being added because its feasible distance is so low. That's why. That's why it's not getting entered in, because it's being advertised in such a high rate. And the reason why it's getting such a high rate is because show run pipe section BGP, because we're advertising it in with such a low metric. So let's actually advertise it in with a little bit better metric and see if that fixes it. So router BGP 65,000. Type in, see here. No, it's not BGP, it's EIGRP. Router EIGRP. Can't type today. It's been like 5 days since I've done this stuff, so it's like I'm out of touch. EIGRP 112. Address family IPv4 VRF green. Autonomous system is going to be 112. And we're going to redistribute BGP 65,000. And the metric that we're going to redistribute it in with is going to be some ridiculously high value. Or very, very, very good value, I should say. So we should do this in at a gigabit. So that's what? 100,000? That's 1 gig. Gigabit, we're going to say is going to be 1. I'm going to say is that 1, and then we're going to say 1500. Oh, and 1500. So the reason why we had it so low before is because we redistributed it wrong. So now if we were to go to 13 and then do a show IP route, the route should come in much, much better. So 3072. So now it's coming in at the same rate as the other guy. So now if we were to do a trace route back to that, oh no, it's not getting advertised. Oh, there it goes. Woohoo! I got ahead of myself. That's the reason why it wasn't working, is because of the. So these are things you should be watching out for. That's if you stuck with me through this part of the video, that's a good reason, because that could be a question on the troubleshooting section. It could say, central services VPNs have been set up between on 9 to where we have an import-export policy to certain routes, and router 13 can't connect back to router 19. Fix the problem. So it could be a metric problem. And in this case, the fact that I had the metrics set too low, so therefore it wasn't being installed in the routing table. If I was to go to router 10, and I think I did this in router 10. No, router 13, I'm sorry. I did it on 13. No. Was it in the... It was in the routing table previous to that, and this was the really high metric. It was on router 10 that it wasn't getting put in. So we're going to do a show IP route here, or show IP route VRF green before green. Alright, so before it wasn't getting advertised, it's still not getting advertised. Oh, there it is. Now it's coming as a BGP route. That's why. Alright, so it literally just got added to this. So it's coming as a BGP route. And the reason it's coming as a BGP route is because of the fact that it's been advertised as the correct value. So now if we go to 13 and do a show IP route, it's coming in as an external route because we're redistributing, and we get there. We should get there no problem. And we do. So it's being routed to 10, and we're good to go. So everybody's happy from the looks of it. Looks like it's working. So 10 to 9 to 19, and then we get to where we need to go. And everybody's good. Now it's actually what it actually looks like it's doing is it's trying to go out to. Oh, no, it's not. It almost looks like it's doing that, but it's not. But we're good. But that's the point, is understanding how this stuff works. And that's why I'm like, I wonder if we were to do this. And it wasn't a redistribution issue, it was a metric value issue. So, and that was my own fault. I don't even try to do this stuff, it just happens to work out to where, as I configure it, it just happens to work out that way. You know, I configure it with some arbitrary value. If I would have configured it correctly the first time, or with a better value, we would have gotten it to work out of the gate. So, now again, you can do this however you like. Now, what I would recommend doing, and you don't have to do this if you don't want to. What I would recommend you do is, instead of setting it up, instead of doing it that way, this is how I would recommend you do it. Now, this is my first time ever explaining this, so excuse me if I sound like I'm new at this. If router 9 is going to be your hub, right? Router 9 is your hub, and these guys are all your spokes. This is just the way, from what I've seen it set up, to make it easy. Well, this is my definition of easy. Everybody's sending traffic this way, so you would go 965,000, right? You're sending it to router 9, and you are a member of Autonomous System 65,000. So you're going to do that. So what I would recommend is, if you're going from router 9 to these other routers, I would flip the route target to be different. I would say go 65,000, like I've done, colon, and then whatever the router number is going to be. So if it's going to be 10, be 1,000. So you know where it's going. Or router 10. Or, I would put in the router ID as the target number, and then whatever the autonomous system is. So, 10.100, 10.10, colon 65,000. Something like that. Now, the route distinguisher and the route target value can be identical, but they do two different things. Remember, the route distinguisher makes the route unique, and the route target tells you which PE devices will be exchanging traffic with each other. So, in this case, router 9 right now is receiving all traffic from all routers. Right now, R9 and R10 are the only routers in the MPLS VPN core that are actually exchanging routes with each other. And the only reason it's working now is because of the fact that I redistributed with a better metric, so that now that the route to router 19 is being advertised to router 13. So technically speaking, you could use MPLS to do 3, 4, 5 things for you. So you could have it set up to be your network management setup, to where you have all the PEs set up to send all the routes to 9, so that the hub receives all the routes inbound, so he's getting all the SNMP set up, all the syslog, all the Active Directory, all that type of stuff on the back end. And it could also be for accessing all of your remote sites. You could have a route target value set up to do on a per spoke basis, to where you only want a particular route getting advertised to a particular spoke. You can have that set up as well. So different ideas, different strokes for different folks is what I like to refer to it sometimes. But play around with this a little bit. I'm going to do my best to play with it and see exactly how it goes. And the cool thing about this is, what I've been doing is, I'm going along and I'm thinking, oh yeah, I could try to do that. I've been taking notes. Okay, is this possible? So can we take a route target, make it unique, and then go in there and advertise a particular route to that particular spoke? Well, I can advertise everything and then do a distribute list. That's easy. But I want to try to limit it in the MPLS side and see if there's anything I can do with that. So, just different theories as I'm going along. So that right there shows you can do central services using a strict import-export policy, and then go in there and have it R9 send traffic to R10, and then R13 receive a particular route. I hope this has been informative for you, and I'd like to thank you for viewing.